Hi, welcome everyone. My name is Meg Berry, the BinarX Outreach Program Coordinator, and welcome to BinarX 2024 to 2026 Payload Development Program Week 2, where we're going to talk about payload team composition, so the kinds of roles that you might take on or might think about taking on as part of your payload development program in your team. So that image is an image of all the hands, or many of the hands, holding the Binar1 bus. So flight computer and control system that built Binar1. It's a very diverse team. It was made up of different individuals with different personalities, different talents, different viewpoints. So before we explore the different roles you might take on in your payload development team, I'd like to take a moment to talk about why diversity and inclusion are important when taking on any project, and BinarX is no exception. Diversity of personalities and ways of thinking is crucial in a team, including for you as students developing hardware and software for our Cube satellite payloads. Diversity fosters innovation, as different perspectives can lead to unique solutions to complex problems. So a group of individuals who all think the same way and have the same perspective are probably not going to come up with different solutions. They're just going to sort of come up with the same solution. So if we introduce diverse perspectives and diverse personalities and diverse experiences, we're going to come up with some creative and novel solutions, and that leads to innovation. So not only innovation, but it promotes resilience in the team, strength. If you're resilient, you can battle through the hard times and the challenges, because varied skill sets and diverse skill sets and ways of thinking ensure that your team can adapt to unforeseen challenges. For instance, a team member with a detail-oriented personality might excel in hardware assembly, which takes a lot of focus and a lot of patience, where another team member who's got a big picture mindset, who might seem like a creative thinker and sort of all over the place and out there, might be really good at zooming out and coming up with the big picture mindset and conceptualizing the overall system architecture and what you're going to do. So the blend of diverse minds can significantly enhance the team's problem-solving capacity and creativity, and drive the project towards success, and come up with some really unexpected, wonderful solutions and even questions. So engineering isn't just programming and hardware. It's about solving problems in innovative and creative ways. Engineering is a mindset. It's a design thinking process. So it's there's so much more to it than just hardware and software, even though that's a very fun and cool part of it. Teamwork, respect, inclusion, and communication are really critical as values. I really believe it's something that means a lot to me, that the way we work together is as important as the work we do. So be sure to listen and consider each other's ideas. You might be surprised. You might not think that someone's got input that's valuable in a certain way, or that they're not paying attention, but really just let everyone be heard and respect their views, and the team will be stronger for it. Everyone has something to offer. We all have different skills, but everyone has value and a place at the table, and a place on a team. So as you and your team progress through the BinarX program in the coming weeks and months, be sure to note down highlights, challenges, wins, and surprises, because this will help you tell the story when you create your posters and present your team's journey and findings at the end of the program. Because it's not just about having the payload at the end. You want to talk about your growth as a team and what you've learned about each other and what you learned about yourselves, and your growth through it, because that makes a really compelling story and helps us communicate our work and share our work, and also reflect on our work at the end. So please, whether you've got a physical notebook or a OneNote or somewhere where you can drop in your thoughts as you go, it's a lot easier doing it as you go than trying to do it all at the end, because it's hard to remember 6 months down the track what was difficult at the beginning, because in 6 months you're really going to know what you're doing, and you'll forget that you may have struggled with certain things at the start. So before I talk about just general team roles, I'd like to introduce you to some of the team at Binar and the Space Science and Technology Center. So the SSTC is within the School of Earth and Planetary Sciences at Curtin University, and the Binar Space Program sits within that. So one of our founders and director of the SSTC, distinguished Curtin Professor Dr. Phil Bland, he's there with his dog Bear. He insisted on a silly headshot and not the stuffy ones like the rest of us have. He's the blue sky planetary research person. He's the big thinker. He thinks about these big ideas, and he does the strategic planning. So I went around and asked the team before this week's session, think back when they were in high school like you are, and what their favorite subjects were, what degrees they did post-secondary, and then how they ended up with us at Binar and the Binar Space Program. So Phil loved English language and writing, and his path was sort of a nonlinear one. He he didn't have the financial resources to do a PhD after uni, so he did PhD part-time, worked in the industry, just found a really creative path and a really unusual path to Binar, and founded Binar after starting the Desert Fireball Network, which you might remember is where is where a lot of our team started, and the camera network out in the desert that captures things in the sky that shouldn't be there, and then we go hunt for meteorites because luckily they're meteorites. So from that, he started the Binar Space Program as an engineering arm to achieve planetary science research objectives. So rather than meteorites, he wanted to go out and explore in space, and so Binar was born, and that's pretty amazing. Renee Sayers, who, if you haven't had a chance to meet her, is fantastic, but you will know if you've met her. She's very energetic. She lights up a room full of policymakers and politicians like no one else. She's an astrophysicist. She's also the Space Science and Technology Center Deputy Director, and she has leadership of the Binar Space Program and BinarX, so she's my boss. And she's fantastic. So she loved drama in high school, and she's very she's done work in theater. She's done work at SciTech as a science communicator, but she's also got a degree in astrophysics and studied psychology and philosophy. So it's not only engineering subjects that can bring you to this kind of the space industry. There are lots of other ways of doing it. So she started in the space industry with an email to NASA as a 16-year-old, and then 20 years later, degree in astrophysics and a career in STEM engagement around the world. And now she's leading the Binar Space Program, where she continues to forge novel partnerships, creative collaborations, and ultimately empowers people to see STEM in a new light. So she definitely activates STEM and space and sciences of all kinds in a really dynamic and engaging way, and that's really fantastic. Dr. Robert Howie, he is a research associate that teaches the tertiary units at Curtin that we base our payload development program on. So if you do continue on to engineering at Curtin, you may very well end up with Dr. Robert Howie as your lecturer. He loved physics and did a double degree of engineering in mechatronics, which if you don't know, you should look into. It's a very interesting engineering discipline that blends sort of mechanical electronics and software engineering all together. It's underpinned by a lot of the first robotics and robotics challenges. A lot of those mentors are mechatronics engineering students, so it's quite interesting. And he worked with Phil during his PhD developing the Desert Fireball Network, and he continues to work on engineering to enable planetary science within the Binar Space Program. And he teaches, as I said, Curtin spacecraft design classes. So those are really interesting. Students develop their own payloads, much like you're doing, but with like a little bit more of an advanced bend on it. So it's very interesting. This is exactly, his course material is exactly what we've based this program on. So it's very much a real thing, and you'll find that a lot of what you learn in the next couple of years will be applicable if you choose to go on this pathway beyond high school. Fergus Downey is our senior engineer. He is currently probably one of the most senior people at Binar in terms of seniority, because he's been with Binar 1 pretty much right from the beginning. He loved economics, maths, and parts of physics, he said. I'm not sure which parts. And he enjoyed creative writing, but wasn't very good at it. Again, a Bachelor of Mechatronics engineer and a PhD with a gap in between to go traveling, and he just came back in the last few months. And if you read up on how he ended up there, it's just asking around in luck and looking at opportunities and taking those opportunities when they present themselves. And that really is part of finding your path is just keeping your eyes open for those opportunities. We have Nick Rogers, who's our space lawyer. He does launch operations and legal compliance. So again, not just engineering disciplines in an engineering or a space mission team. There are lots of legal compliance being, you've got to make sure that you're doing things according to policies. So space is a very international thing. So there are a lot of treaties, a lot of considerations to be made, a lot of international collaboration. So there's quite a lot to do on the legal and sort of almost diplomatic side of things. And actually Renee works a lot in diplomacy as well. So again, space is engineering, space is diplomacy, space is law. It's amazing. So what he does at Binar is he navigates the domestic and international regulatory frameworks, so all the rules between countries and bodies, to get the satellites into space. So he's got to write to the government, get permits to export, because there's all this, all this paperwork that you've got to do and all these applications you've got to make. You won't have to do that for your payload. We do that part for you. But it's, it's well worth knowing if you have an interest in law that you can work in the space industry as well. You don't have to be interested in engineering. So he deals with the Australian Space Agency. He deals with the Department of Defense. He deals with the Australian Communication and Media Authority, and also international organizations like the ITU, ESA, Space BD, who are our launch brokers. They're a Japanese company that basically get our ride shares for our CubeSats up, and then they deal with the Japanese Space Association. And he also deals with launch providers directly, like SpaceX, who we spoke about, and we launched on the SpaceX rockets previously, and we are launching again in August on a SpaceX rocket and a rocket lab. Hugh Cook is our instrumentation engineer, so he's very much an electronics engineer, but did a bachelor in mechatronics engineering at Curtin, and he's doing his master's in electrical engineering. So I'll let your teachers read through. You can go back and read through the how they ended up in the space program, but it's really interesting. Everyone's got a story about asking the questions, looking for the opportunities. Chelsea Tay, she's one of our embedded software engineers. She loved mathematics and she did a Bachelor of Computer Science. And again, she started off as a Bintern, we call them. So we have an internship program at Binar for undergraduate university students. It doesn't have to be Curtin students. We've had students from other universities, and they all get given really meaningful work as interns, and that's really important to us. They're not making photocopies. They're not running for coffee. So her first project was building up the ground station software. So we'll talk more about ground stations, which communicate with satellites on orbit. To communicate with ESA's SMILE facility. So if you look into that, that's the European Space Agency's basically testing facility that members can go in and test their satellites' communications in sort of a real space environment, well, simulated space environment. And she also had to make the software compatible with Fugro's mission control station. So Fugro, if you don't know, also worth Googling, they're a Perth company that started out in remote operations for subsea and then have moved on to being in the space industry, and they're actually working there now, and we have past Binar staff members who've gone on to win either internships with that group, with Arose and Spark and Fugro, or we've actually got some people who've gone on to have paid positions with them as well. One of whom is working currently on the lunar rover project that we are trying to win in Western Australia. So yeah, right now she's working on Binar 234's flight software. So Binar 234, as I mentioned in previous weeks, are launching in August. So 3 satellites launching in August and should be on orbit in September from the International Space Station. And she's currently still working on both the Binar 234 software and ground station software. So she's working on the software for up in space, and she's working for the satellite, and she's working for the communication software on the ground. So that's very, very cool. And Justin Ward, another embedded software engineer. He loved biology and physics, so that led to a Bachelor of Physics in Nanotechnology and a Master's of Software Engineering. So again, he wanted to complete an internship over summer with Binar, and he loved it, so he completed his master's thesis in robotics with Binar, and then got a job straight out of that as an embedded software engineer. And he's done a lot of work on the payload development kit, along with Lorian Marshall, who has now moved on for an internship with Fugro. And we'll talk more about that, but you'll learn about that in coming weeks. So everything that we're using as part of this program was made by these people that I'm introducing you to, and it's pretty amazing. Hans Benz, one of our only mechanical engineers, he also reached out and offered to help around the lab, and he ended up doing some small projects and then got an internship with Binar, and now he's coming on as a casual, and he's working with us. I think he's pretty much full time now. So he's a test engineer, and he's working on his thesis currently is a deployable boom, so a boom that sits in the CubeSat like our deployable solar panels, but in this one it's going to be sort of a telescopic arm that pops out for instrumentation. So everyone just figures out what they want to work on and how it's applicable to Binar as a spacecraft, and within your payload teams you can find out what interests you in terms of roles that you could take on. And then from there, you can explore those passions and have them benefit your team. Charlie Morley Wong, he's a student casual engineer, and he was our high altitude balloon project lead. So if you have a look at our Instagram, so at Binar Space, you can see some of our footage and photos from our high altitude balloon launch in Meriden a few weeks ago. And Charlie's only 22, but he led the project. He ended up being interviewed by the ABC on the radio about it, really, and was really confident. And we do actually have documentation on the high altitude balloon, which reached 29.5 kilometers, so mid-stratosphere, and took a photo of the curvature, showing the curvature of the Earth from about 16 kilometers up. We got a photo. So that's a really great activity that I encourage you to look into as well. And we have documentation that can support you and your teachers if you want to do that, because it's a really great way to test your payload. So we're not going to be launching on orbit in a satellite for a little while, but there are those fun things we can use to test your payload and get data and improve our payloads before sending them to space in the meantime that don't take as long to plan. Daniel Turner is a propulsion engineer at Binar, so he's working on everything for a CubeSat has to be miniaturized. So Daniel Turner was recently featured on the news with his miniaturized hot gas thruster. So it's a tiny little AA battery sized thruster. He's only 25, 26 years old, and he's working with German Space Agency and European Space Agency, and is going to be hopefully putting his thruster on our lunar mission, which is the 12U CubeSat or Lunar Prospector. So you should look more into that. And he did mechanical engineering as well, and is currently working on his PhD. So how he ended up in the Binar Space Program, he loved things that can fly, particularly spacecraft and aircraft, and he took the Space Systems Engineering class at Curtin, which was Robert's class, and he realized his true passion was spaceflight and spacecraft engineering. So, he's doing incredible things as well. Kyle McMullen, whom I mentioned before, developed the compliant material alloy for our deployable solar panels that pop out of the CubeSat. That's his role. He does spacecraft dynamics, so deployable solar panels and attitude determination and control systems. So you remember attitude is which way the satellite is pointing. We can't go up or down without a thruster like Daniel's making, but most of our 1U CubeSats don't have propulsion, but we do have attitude control with that magnetic field magnetorquers that we discussed in previous weeks and we'll talk more about. That's his focus. So he loved physics, but he also loved Western art and music. So again, diverse perspectives, diverse interests. It's a team of many hidden talents. Kyle teaches parkour, for example. So he did a Bachelor of Mechatronic Engineering, and he's currently doing a Doctorate of Philosophy and Mechanical Engineering. And Alex, who's our PhD student, he is in the team, and he's still looking for specifically what he's going to work on within Prospector. He's working on navigation for Prospector, but he's a mechatronics engineer, and he's working towards his PhD in engineering. So he came to be a part of Binar after meeting Robert Howie, who teaches at Curtin at the Space Industry panel, and he spoke to him and then was offered an internship. So from there, that led to an offer for a PhD opportunity, and now that's what he's progressing towards. So, it's a very real pathway to coming into undergrad, figuring out what your passions are, and then from there, if you want to work in space, there are so many different roles. So what we'll get into now, and me, of course, I've already talked lots about me. I'm the BinarX Outreach Program Coordinator, so I have, other than being a big geek, no real formal science background. My favorite subjects in high school were Comtech, which you might call design technologies now, and history. So I did a Bachelor of Graphic Design in Canada, and I've also done a diploma in project management. So I think I love them both. And how did I end up here in Binar? So to steal a quote I heard during IPSEC 2023, which was the Indo-Pacific Space and Earth Conference, I followed my smile. So I was a volunteer for First LEGO League, which I mentioned in session 1, and I loved being a mentor. I loved being a judge. It was something I was doing, after school with my kids and the student school community, and working with Tim Keeley at Curtin STEM Outreach to work in judging in First LEGO League. And then so I had a little bit of experience setting up STEM clubs and running them and doing all the things that you need to do to STEM club. And now I get to do that passion project every day for a professional career, and I'm really thrilled and really privileged to do that. So we'll get into what your team roles might be in terms of your payload teams. So we talked about project management, so keeping everybody organized effectively, keeping the work organized, knowing what tasks are going to be done, and then keeping an eye on your deadlines and sort of tracking, seeing how everyone's tracking and making reports on that. So it's also, you've got to think about the task to be done and break it down into chunks. So you don't want to just say, okay, we're going to make a horizon sensing payload. It's like, okay, well, what do we need to do? We need to first identify requirements. We need to, figure out what we need to do, pick sensors. You get these little tasks, and then everyone can work on them individually, and you can see when they're done. And it's very handy to have something to refer back to see, if you've forgotten about something. We'll talk more about project management in future weeks, but it's a really great. It's quite interesting. I'm not a terribly naturally organized person, and having gone and done a diploma of project management has really helped me sort of get my creative, messy mind and harness it and channel it into being something that I can collaborate with others a lot more easily, and I can keep track of my own tasks in my own time. So project managers create and review a lot of these project management documents. They develop, revise, and maintain project plans. So that's not just plans for what you're going to do, but budget, time, scope, stakeholders. So we'll talk more about stakeholders in a little bit, and coordinate the team activities. So you might go check in, you might have your software team and your hardware team, and you're going to help them. You're going to facilitate them collaborating, and you're also going to help them with their task tracking and make sure everyone's, on the same page. The systems engineer, which we may not use for this one because that's more of a full spacecraft project, but it's someone who would look across all the disciplines. So in software, hardware, mechanical, engineering, law, they would look across the disciplines instead of drilling down into individual disciplines like software or hardware. They zoom out and they look at what everybody's doing and make sure everything's going to work together. So if you have a washing machine, for example, and you've got someone working on the motor and someone working on the circuit board to drive the motor, if they just design independently and don't talk to each other and don't integrate what they're doing, they may not end up working together. So the systems engineer does that high-level systems design and make sure that the compatibility, that all the different parts work together, basically. And then works with the verification engineer to do testing to make sure that, because we test before we fly or before we launch. That's very important. So mission scientist, if you're more interested in the science and the research side of the questions, you can basically liaise with the stakeholders to refine a mission need. If anyone knows what a stakeholder is, it's someone who kills vampires. No, it's not that. A stakeholder in the context of a project is someone who's interested in your project and the outcome and what's going on. So there are actually lots of different stakeholders. You have your main stakeholder, say your client or who's paying for it. So if you were being funded by the Australian government, or whichever department, they would be your main stakeholder. But you'd also have members of the public, because they're interested in what's going on if you're doing something environmental. So say with Rita Jones's forest moisture content payload, not only would the Department of Emergency Services be interested in the moisture content of Western Australian forests to help manage them, but the general public would be interested as a stakeholder to know what was happening in terms of bushfire management. And so that would be another stakeholder. So maybe think about who's interested in the outcome of your project, and you can brainstorm that and come up with it and talk to your teachers and maybe make some notes and think about that. So the mission scientist will develop technical requirements to meet mission needs. So I'll go back again to Dr. Rita Jones's payload with an infrared sensor to detect the moisture content in the forests in Western Australia. She would advise and do she would know what band she wanted to look at, so is it going to be a UV sensor? Is it going to be an infrared sensor? She says, no, it's an infrared sensor. That's what we need. This is what I want to measure and help, and say what it is that has to be measured, and then work with the engineers to make that happen in terms of a technical and practical sense. So model operation of the payload. So if you have a look at our Instagram, you'll see some models of her payload, which is a simulation, because it's quite handy to model the expected operation of how your payload will go. So for example, you have a payload, you'll model how it will go on orbit, where it will point, where it will be gathering the data, and run those simulations prior to actually launching. You'll also, as the mission scientist, you'll also support the development of payload electronics and software, and support with the development of data processing software. So you'll work with the engineers to make the thing, and then once the thing gets the data, you'll need to visualize it in terms of, or process it, because you'll just have all this raw data, and it won't mean anything until you interpret it. So that's part of your job as the mission scientist as well. You'll also have some stakeholder management and engagement. So again, the stakeholder, the persons or groups who are interested in or invested in the outcome of your mission. And then, yeah, payload sensor selection and modeling, and assist with hardware and software development. So it's a very interdisciplinary team, and everyone does work together rather than in isolation. So everyone will have a chance to work on a little bit of everything. Electronics developers, that would be like your Jacob Cook from earlier on, electronics design, prototyping, soldering, the hands-on hardware stuff. You'll also support system verification, which is testing and making sure that the payload does what it's supposed to do before you launch. Software developers will develop the software that go along with the hardware. So in the case of the final payloads that we do, so if you're working on the Introduction to Electronics boxes right now, it's the Arduino microcontrollers, which is in Arduino IDE, but in the next phase of the development program, we will be using STM32 IDE and STM32 microcontrollers, which code in C or C++. It's not altogether different from what you're doing in the Introduction to Electronics boxes if you've started those, but it is a little bit more difficult, but that's why we start with the intro boxes and then we move on, and we will support you through this process, of course. Software developers will also work on software testing, so debugging, making sure that they run it as many times in as many conditions as possible to see if it crashes or has errors, and making sure that that's rock solid before it's time to launch. And verification engineers. So again, once the software and the hardware engineers have done what they need to do, there's going to be a list of requirements that the payload is doing, and the verification engineer has to verify or make sure that that system and that payload is doing what it needs to do. Also, that the system is getting the data that's going to meet those stakeholder needs, so that you're getting, again, correct moisture content for the correct area in the case of the payload that's monitoring Western Australian moisture content in forests and bush areas. So your duty as the verification engineer would be to say, how are we going to test it, develop those testing procedures, carry out the testing, and record the results, and then analyze those testing results. If you can't actually test because there's no way, but there are lots of things we can do to test or to simulate. But if you can't test, so for example, when we launched the high altitude balloon, we didn't know exactly where it was going to land, so we had to model where it was going to land. So we used some computer software to say, okay, well, these are the different things that are part of it. This is how high we think the wind is going to be. This is what time of year we're going. This is how much helium we're putting in. How far is it going to go? And then that at least will give you some idea, hopefully, if your modeling is good, about how it's going to behave. And then inspection and measurements. So, does the payload meet voltage requirements? Does it meet mass requirements? Because it's, is it too heavy? Is it too big? That is really important too. So, in the communications office. So this is, and you can all work on different parts of it. You may not just stick to one role within your payload team, but it's important that that people do have a clear idea of what they're doing, and so that we can all do a better job and a more efficient job working on a team. So the communications office could manage communications with teams and external stakeholders. So basically, the media or your schools or your parents, or presentations at your assemblies about what you're doing. You'll all work on these, but you'll all contribute to these. Your whole team will contribute to it, but you could have one person who's sort of doing the presentations or the posters, or a couple of people who are doing that. Prepare and revise written, visual, and audio-visual communication. So you could also be recording little clips. If you've got a media unit that you're doing, you could put together a little documentary video of your team journey as you go through, and have that as something that's available. And develop and apply team branding. So, your team name, your team logo, your team colors. Don't underestimate the power of, a really strong brand in getting people's attention, and keeping your communication clear, and keeping your message understood as you intend it to be understood. So there are lots and lots of ways, and of course, legal and compliance. If your payload is, if there are components on your payload like an atomic clock, which is not only very expensive but export controlled, what does that mean? You can look in, if you're interested in international and local and federal laws and rules that go around space operation and intellectual property. This could be the job for you. Just see what things might apply to your payload and your activities, and advise your team on those matters. and prepare presentations and reports, because compliance reports can be useful in taking key business decisions. For example, the building industry's had a big shakeup a few years ago. The combustible cladding was going to be banned, and that was coming for a long time. So if you were a manufacturer of cladding that could be combustible, you had to start thinking about how you were going to change your business to suit for that. And the next one is the engineered stone. And so, my background, I have some background in building and manufacturing, so I was aware of those things and knew they were coming. So as someone who was a project manager and doing a little bit of everything, I had to keep an eye on what was called compliance to make sure that, if I were planning projects for a year or two in advance, I knew what was going to be allowed, what was going to be allowed, or what other considerations need to come in. And also, health and safety, financial risk legislation, all things you can look into and see what might suit you best. So I'm not there with you today, but if you pause here and go around and get to know each other, talk about your name, year level, favorite space-related TV show, movie, song, or book. I'd love to know what you are most looking forward to in this program. If you could even write it down if I'm not there in person and email it through, that would be great. And start thinking about forming your payload teams. You don't have to decide now, but just have a think, as you work on your science questions and your payload questions or your creative questions. Start seeing what you have in common or who's got an interest in common, and then talk about the roles and see if you can flesh out a nice, well-rounded team. All right, so thank you for listening. So next week in BinarX will be week 3, which is a CubeSat and space mission case study research activity. So you'll have time, you'll need your computers or access to a computer or something, a tablet, where you can research and summarize a past CubeSat mission and payload that interests you. We'll send through some resources on what you might to look, but just, even just a web search. There's tons of resources out there. There is the journal from last week that I sent through if you want to have a look at that. Continue brainstorming your BinarX payload mission concept, and then we can finalize our payload teams. Again, if we don't quite finalize them, then that's not an issue, but the sooner we decide on our teams, the sooner we can sort of keep moving forward. And again, if you have any questions, please have your teacher just email through to binarx@curtin.edu.au. And get in touch with us, and we'd love to hear from you, and we'll do our best to answer our questions as quickly as possible. So thank you, everyone, and we'll see you next week. Bye now.